Hey, this is Mr. Hendrickson. The goal of today is to increase your background knowledge on displacement, velocity, and acceleration graphs in order to prepare you for the physics dance party lab. So, let's do a quick review on vocab and what we already know about motion. So, the first term you need to make sure you know is displacement. And of course, that's just telling you how far you are from where you started. Displacement can be positive or negative. The direction matters. So what I'm talking about here is if you are moving away from where you started, you are displacing yourself from your original position. Okay, your displacement can also go down though, because you can return back to where you started and have actually less displacement. I'll show you some examples in a little bit. So here's a displacement time graph. What you see here is that as time goes on, as you move to the right, you see that the displacement is going up. So this particular object is moving away from its original position. In another example here, we see that as time goes on, as you move to the right, time is progressing, we see that the displacement is going down. This object is actually getting closer to some position as time goes on. Keep that in mind. Now that we've got displacement out of the way, we can look at our next piece of vocab, which of course is velocity. We know velocity is the rate that we're changing our position, or the rate that we're changing displacement against time. And when we talk about velocity, your direction matters. So, your velocity can actually be positive or negative. Your velocity is going to be positive when you are moving at some rate away from a position. Your displacement is increasing, you're moving away. You can also have a negative velocity though, and that occurs when you're moving towards some position. Your displacement is getting less. The first example we're going to look at is a constant velocity moving away. For this example, take a look at a quick video of my daughter walking away from the camera. What you'll notice is that she's displacing herself away from her position at a constant rate. Let's take a look at this displacement time graph and think about velocity. So again, as time goes on, we are moving away from a position. Remember, earlier on, just last week, we talked about how velocity can be found by taking change in displacement over change in time. Or in other words, the slope of a displacement time graph. If you look very quickly at this graph here, we notice that the slope is going up. We see a positive slope. Notice also that the slope here is constant. Okay, it's a straight line moving up and to the right. So that tells us that there is some velocity. If we were to draw the velocity time graph that matched this displacement time graph, it would look something like you see here. First, the velocity is positive. It has some value. Secondly, it's constant. And again, we can tell that because we have a constant slope over here in the velocity versus time graph, meaning we'll have a constant value, or in other words, straight across line here for our velocity. For the final example, we're going to look at an object moving towards some position at a constant rate. This video shows my daughter moving towards the camera at a constant velocity. As you move to the right, you should see that the displacement is decreasing. Ask yourself, before we even move to the next slide, what is the velocity here? And the way you can figure that out is ask yourself, what is the slope of this displacement time graph? You should notice, again, as you move to the right, the displacement is going down. It's a straight line, so the velocity is constant, or the slope is constant. So what you see here, again, using the slope of our displacement time graph, is that we have a negative constant velocity. So in other words, it's in the lower quadrant because it's negative, and it's straight across because it's constant. This tells me that my object is moving back towards its original position at some constant rate. What do these graphs both have in common? Well, of course, they both have in common that the velocities are constant. Both straight across. In this example, it's positive, so the object is moving away. This example, it's negative, so this object is moving closer to some position. But based on both of these graphs, could we find the acceleration? I think we could if you can answer this question down here. How do you find acceleration in a velocity-time graph? Of course, you should remember from last week, velocity versus time graph. The acceleration, of course, is just defined as change in velocity over change in time, or in other words, it's the slope. What do you notice about the slope of both of these graphs? It should be very obvious. In both examples, you have no slope. They're both flat. So that should tell you here, ladies and gentlemen, that our acceleration is 0 meters per second squared. These objects are both moving at a constant rate. So if I was to actually plot out the acceleration versus time graph, of course, it would just be a plot right over the origin here because, of course, we know that the acceleration is 0. As time goes on, as we move to the right, the acceleration doesn't change.
For the final example, we're going to look at something a little different. An object that's moving away while slowing down. Take a look at the video. Notice she starts fast and ends slow.
In this example here, we see an object that is plotting the displacement versus time. So as time goes on, we see that the displacement is going up. But it should be very obvious here that it's not a straight line. We see various rates of change here. Early on, we see one form of slope. In the middle, we see another. And then at the end, another. So let's ask ourselves, how do these slopes compare? You should notice that early on, it's a very steep, large, positive slope. As time progresses, notice that the slope is still positive, but it's not quite as big as it once was. And at the very end, the slope is also positive, but it's almost flat. It's almost 0. Remember, the slope of this curve is the velocity, pardon me. So if I wanted to plot velocity versus time, I just need to ask myself, what is the slope of my displacement time graph? You should notice that very early on, the slope is very large. In the middle, the slope is positive, but not quite as big. And then at the end, the slope is very small and approaching 0. So the slope of our displacement time graph tells us our velocity versus time. And what we see here in our displacement time graph is that the velocity is going down. Our object is slowing down as time goes on. We can also tell from this graph, though, that our velocity is positive. That means that our object is moving away from some position. So what we can say here is that our object is started out moving quickly. As time goes on, it moves slower and slower. But throughout the whole graph, it's moving away from where it started. So, what would the acceleration of this object be? Well, remember, we're starting out with a large velocity and ending with a small velocity. Our velocity is decreasing. Another way you could think of this, remember, is that acceleration is the slope of a velocity time graph. So, if we look at this graph, it's a straight line. It has a constant slope. The one key feature that you should notice of this graph is that the slope is negative. As you move from left to right, the velocity decreases. So, if we look down here, we notice that we have a constant acceleration that is in the lower quadrant, so it's negative. So, this gives you a general idea of how I want you to think of these graphs. What you need to understand, velocity, remember, is change in displacement over change in time. And acceleration is change in velocity over change in time. You need to focus on the slopes and ask how they change to find one graph or another. Your displacement, velocity, and acceleration graphs are all related, and you need to use them to find the others. So shortly, you're going to be given various graphs, and your job is going to be to find the other two that are missing. Do your best to work on these in teams, and there is an answer key available, so please check your work when you're done. If you're not sure how to do this, do not stress out about it. We're going to work on it more tomorrow and Wednesday as well. Good luck.